Brilliant, thank you everyone. Before we get started, I want you to do three things. One is to make sure you've got a pen and paper because we're going to try and learn you something, so make sure you got it. Two, put your hands up if you're listening. Right, so if there's somebody next to you who's not put their hand up, give them a nudge. The three, because I said I'd do this last night, I want everyone to take a deep breath in through the nose, and as you exhale, just go, ha! Cool, right, you're all daft now, so puts everyone on a level playground. Cool. As I said, I'm Simon Seabrooke. Graduated 3 years ago from this very place, so I've got home advantage. I'm the rail sustainability lead within McDonald's, trying to upskill our capabilities and understanding around the environment, biodiversity, the social aspect and the economic aspect. But by day, I'm an overhead contact system engineer, putting the washer line above the railway. So I was born at 360 parts per million CO2 in the atmosphere. That was kind of self-explanatory. That is a 38 parts per million increase the 28 years before, and 28 years later, so now it's a 55 parts increase. So not only is it increased, the rate of change is increasing. So just bear that in mind. I'm really happy now that over the last few years, we've gone from why we need to decarbonise to how to decarbonise. We're no longer having to battle people about what climate change is, why it's a thing, it is a thing. We all know now it is a thing, and how are we doing it? How are we in this room playing our part in decarbonising? So really happy to be able to get onto that bit of conversation. It's a bit of audience participation. So hands up if you agree with statement one. Right, yeah, got a couple, got a few. Right, and hands up if you agree with statement two. Yeah, there's a big. So hopefully you can see the parity I'm trying to do. This is not a dig of anyone again who has an electric car part to play, but again, just trying to make the point, it's not the be-all and end-all answer. So switching to tractive power alone doesn't mean we're delivering a carbon-free or sustainable railway. I know people argue with me on that, but I'll stand my ground. It isn't. If we're doing things as usual, doing electrification as usual, we're not doing it as the best we can. The embodied carbon is a huge part of that electrification process. So the Scope 3 emissions, which is the value chain, things kind of build and bought infrastructure, is 97% of Network Rail's Scope 3 emissions, just to use a big infrastructure owner example, and 63% of that 97% is the built and bought items, the things we're putting in the ground, the masts that we're putting every 50, 60 metres, the tracks that we're digging out to low through the bridges we're reconstructing, the power supplies we're putting in. So all of those is the vast majority, not the trains. We all know this is why we all kind of like working with rail. Trains are really low carbon. We all know it's 1.4% of the UK's transport emissions. It's already really low carbon. So, but there's a huge amount of carbon in the infrastructure we're all putting in the ground and designing for. So understanding the policy and the industry drivers will help us all drive decarbonisation and direct the efforts we're trying to do throughout our projects. I know I've said we don't need to talk about why, but how, but this is a little bit going back about why in a very kind of micro sense of rail. So a bit again about Network Rail drivers, science-based target initiative. Hopefully everyone who's a supplier in this room is aware that by 2025, Network Rail wants 75% of their suppliers to be signed up to science-based target and have a robust emissions reduction plan. And when you sign up, you've got 2 years to make this plan. Next one, PAS 2080, so it's just been updated. PAS 2080 is the carbon management and infrastructure standards, how you map your carbon through a project, how you decarbonise it, how you plan to reduce it, and who the front lays with. And then again, another one is a lot of people will be familiar with 015, which is carbon accounting above £1 million projects. And some other ones, again, very much focused on the UK. Climate Change Act, which was ratified again in 2019, holding them legally accountable. The Environments Act in 2021, more around the kind of biodiversity side and management. The procurement notices, 0620 for kind of social value, very much a post-COVID, how we're getting back to it. And 0621 about carbon, and again, similar to the challenges on Ireland, the no new diesel-only traction, asterisks, beyond 2030. So we're all kind of aware of the challenges, trying to teach subjects. But yeah, electrification alone does not deliver a low-carbon railway. Again, like I said, 97% of the emissions from Network Rail are in the things it puts in the ground, and the emissions associated with the new rolling stock we need to procure for those electric railways is also adding to the embodied carbon. And this next bit I think it's very much going to contradict the leaflets you get out today, but it's very much through numbers. So if you take the hard and fact industry figures that are in the TDNS and are in the, make some assumptions like 16-hour running days, and the RIA published emissions per kilometre for diesel and electric trains, you can very much work out your curve of how many trains per hour through that section will deliver you a return on your capital carbon. This is very basic numbers. There's all things. This doesn't include the carbon for the new trains, but it doesn't also include the carbon reduction of the Sparks effect, so getting people onto rail. And it'd be good to debate this with people afterwards, because it was kind of, it's a baiting slide meant to shock, but if you use the hard and fat numbers, this is what you'll get. So again, so what do we do? So we can look at it from a decarbonisation from a volume, the amount of stuff we're putting in the ground, or an intensity point of view. How intense, how carbon intense are the things that we're putting in the ground? Do we build less? Do we are looking at partial electrification? What does that mean for the network that we're doing? We're putting out there. If we know that the bit of electrification we're doing won't provide electric paths for all the trains we're putting through the section, can we do partial electrification anyway? And the answer depends. Isn't the point of this presentation, but the question that do we build smarter or less intense? The answer is yes. Kind of one of the bits I like to put in the frame of mind, if anyone knows York Station or the York area, I grew up in York and from York, is the fact that it's been electrified since the 70s, 80s, and the vast amount of services through there are still diesel. There's a bit of improvement with the Transpennine bi-modes coming through, but a lot of the local services are diesel still, because we haven't provided the electric paths for all of them. We're just providing the ones up and down the East Coast main line, making the points. Cool, so, well not so cool, we are in a climate emergency. Hopefully, again, we all know this. And kind of you don't have to put your hands up, but kind of hands up who's got young loved ones, children, grandchildren even. Just put your hands up if you have. Have you talked to them about how they're feeling about the climate crisis at all? Have they shown any emotion? Because climate anxiety and eco-anxiety is real. I've had it. I've come to terms with what my place is in all of this, what part I have to play. But it is real in a lot of young people, and even adults now, the climate crisis. So yeah, employees to talk to them. But we are in a climate crisis. We're polluting now to reduce future emissions. I think that's pretty acceptable to say. We've already locked in a certain amount of global warming through the carbon we've put in. So even if we could decarbonise now, the temperature is going to keep going up. And so our actions now, putting more carbon into the ground, is again locking it in for future generations. So is it acceptable to build schemes now with break-even years into the future? And how do we bring our embodied carbon down now to combat climate change in the future, bringing again that payback forward? And this is the important bit. This is kind of getting to the section where you need to start taking notes. Hopefully you start taking notes, because I'm trying to get a bit of what I've learned through my investigations on why we're carbon accounting, how do we do it meaningful, how do we create those conversations. So yeah, this is the next bit again. So get into it. So how do we decarbonise and bring back that payback period forward? Prime tool is starting to decarbonise. If anything, it's understanding a project's embodied emission sources. And fundamentally, this first step is understanding how to account your carbon. And there are 5 main areas of confusion when I found when considering carbon, which you might have already, people trying to do it might have already seen a bit of parity in this. One of them, what to capture, when to capture, availability of data, data usage and baselines, and quality of data. Those are the kind of 5 main headings of confusion I've found. That data usage and baselines, I've counted carbon, gone, right, I've got the number on a page, what am I doing now? So it's what we're doing. Have we got emission reduction targets? How am I comparing myself to the rest of the industry? Am I doing well? Do I need to do more? So having that data in front of you is quite vital. Again, so more notes. So what to capture? So it's large and numerous materials and operations, not every little nut and bolt. All the little nuts and bolts we're putting across the railway, there are millions of them, billions of them maybe. But compared to, again, big steel mass, big steel concrete foundations we're putting in the ground every 50 metres, they're pittance. That's not the point. We're trying to capture these big bits, see where the big bits of carbon are across the embodied product, the operations, the materials, and their delivery to the site predominantly. So the availability of data. So where are we getting this data from? So the ICE has databases easily accessible on the internet. They're available via the Rail Carbon tool, the RSSB tool. McDonald's have got their own one, which is the Moata Carbon portal. I'm sure a lot of other consultancies and businesses will have their own versions. So it's got a lot of data for kind of, you've got a lump of steel that's produced in a certain way, and you've got a mass of steel and a carbon factor. You put it together, you get carbon emissions, and you've got, you know, how far your distance is from your procurement. You start to build the picture, so the data is there. You don't have to really do all the research. EPDs, environmental performance declarations, as well. That gives a really good detailed niche view, detailed view of the products you're using. So if there's something you're using over and over and over again, like overhead lines, like registration equipment, if you get an EPD for that, you can see how it plays its part in the entire railway and see if you need to decarbonise that. So they're quite good. So we'll start to build on the collaboration, but EPDs is a fundamental bit of the data. Again, the quality of the data, the ICE gives cradle to gate values for kind of common processes, whether it's a welded bit, or is it forged, or is it rolled in this way. They've all got, someone's already done this research, so they've all got values in there. And again, it's assumptions. You might not think it's very incredibly accurate, but we're trying to get a generalised picture. But then doing detailed dives into common processes, things we're putting into the ground day after day after day, loads and loads and loads. If we do detailed dives into there, we can then start to target the things that are, say, on the 90% of the route, and start decarbonising them. When to capture. PAS 2080, again, lays out a role of who to point the finger at when, and what to capture when, the quality of data, and what to do with that data as you go through a project. And you can overlay this onto PACE. So again, the Network Rail governance process of when to do it. We all know at feasibility stage and option selection stage, you've not got a huge amount of very detailed data, but you can kind of think, right, I've got 30 kilometres of railway, probably going to put up X amount of mass, need to dock down some bridges, let's use some previous data that we've already got, overlay it, where are our carbon hotspots, right, that's cool, let's start and develop the conversation. And then once you've done that, you'll have a number, you'll have several figures, and you'll really identify your hotspots. So then you go, right, which ones, how many are we identifying, how many are we going to do? Are we going to do the top 3, top 4, top 5, top 60%, etc.? Are we going to look on the per design carbon? So for each bridge reconstruction that we're doing, are we going to focus on that? Or are we going to focus on the per scheme carbon, so the per SDK of electrification? This is from the New Buildings Institute from 15978. It's kind of copied across lots of other standards and documentations, but sets out kind of a guideline of stages of when to account your carbon. For large infrastructure projects like electrification, the carbon intensity and the data confidence will reduce through the stages. But everyone in this room, that's why we're all here, we've got consultants, suppliers, constructors, everyone in this room will hold good detailed data for various parts of this cycle. So make those connections today. I'd employ to start making those connections today of who fits in where on this line. I, as a consultant, have a bit of an idea across all of them, but I've been working with the likes of SPL to understand more the construction and the transport, where the material is actually coming from, how many people do they have on site, how much equipment they have on site. I don't know that. I'm mostly sitting behind the screen doing layout designs. But then there'll be people who are taking the waste, processing it. What's the carbon intensity there? What do you actually do with all that material? And the maintenance teams as well. This is my next big challenge. The maintenance team. What are you doing on what frequency basis? Are you replacing the parts? So which parts every 5 years, etc. So yeah, getting that data across all the different industries. And once we've done it once, we can then start to use that data easily and refine it going forward. So where next? So identifying carbon hotspots. This is a bit of a recap with some more detail. So identify carbon hotspots, separate across the life cycle stages, and it'll show the designers where carbon is predominantly coming from. Again, we want to target that 10% by volume, which gives us the 90%, and not the other way around. So we're not chasing, again, all the little nuts and bolts. Improve the hotspot data, refine the data quality through industry collaboration. I'll keep saying it. Identify what was already being done and begin the conversations on where to target. So I can make an assumption and say, oh, you're just shipping all your material up to site on the back of an HGV, but the company might already be doing rail freight. Cool, right, I've made that assumption wrong, but I've not done that. I won't find that out unless I had that conversation. knowledge and power seems a bit cliche, but the knowledge of the designer and the purchasing power of the installer, the scheme owner, can put more emphasis onto the suppliers to pursue decarbonised materials or processes. We have purchasing power, so we can not make people do it, but have a bit of influence. But again, let's work together with those suppliers to figure out the path to a decarbonised product. A bit more efficiencies through collaboration. Again, collaborative knowledge of standards can identify where regulations may be limiting decarbonisation efforts. We've really seen good progress with things like voltage control clearances, surge arresters, collaborating across the industry and authority boards to understand what the risk is, work through that risk together, understand it, bring it down to a manageable level, and then agree it with the asset managers about what is the reliability of that railway if we put something like a surge arrestor in and don't knock down a bridge. But we need to make sure any efforts we do are still safe, maintainable and efficient solutions. We can only do that through refined approaches. The power of digital, I'm not going to go on about AI, but refinement design and construction planning tools, which include carbon emissions, can give you real-time data of the things you're putting in the ground. If we're, some designers, just putting things on a screen, go, oh yeah, that's a mast, that's a mast, that's 8 metres high, you don't really get the context of it. If you could see the carbon ticking over and bringing up, you go, right, okay, I might need to refine that design each time over and over. And digital tools will allow you to kind of see that much more efficiently, as well as construction arrangement, things like 4D BIM. And communicate, again, communication is key. Communicate the opportunities and the costs as early as you can so you can start to do those conversations earlier. Don't get all the way to detailed design and go, oh, I want to put a polymer sleeper in. Get it in early. Get those conversations going with the asset managers, because it's effectively, ultimately, in a lot of terms, it's their railway. So identify those opportunities, costs. Might just be a message to one of your scheme leaders, and you can start exploring it. But just to reiterate, carbon is just one piece of the sustainable railway puzzle. Sustainability being the economic, environment, and social improvement, so social sustainability. Things like if we're electing not to knock down a bridge, are we providing long-term, meaningful and safe connections for a community as we go through their railway? Again, de-veg, route clearance, we're cutting down a load of trees. Is it good enough just to plant them somewhere else? Do we need to rewild those embankments with kind of long grass, bring the local nature back? It needs to be thought and a solution. We don't need to just plough through just for the sake of decarbonisation. There's all these other factors affecting the communities that we serve, the communities we go through. So it is just one part of the picture. So if someone says sustainability and they're just going on about carbon, challenge them about the social and the economic part of it. So vast sustainability and decarbonisation capabilities exist within this room and exist within the rail industry. And we can all use these capabilities to create a better tomorrow. And apologies, it's so cliche. But the things, you can bring them all together. We can all work together to, again, create a better tomorrow. If they don't do it, there's no point. And the world heats up. We are playing our point. It's no point pointing the finger at the other ends of the world and saying, what are they doing? We're buying things from their countries and contributing to the problem. So we're doing what we can within this industry. So a bit of a summary. Decarbonisation begins with understanding how and what to do to capture. Not all data is equal. Understanding data quality and assumptions can lead to those refinements as you go through a project. Hotspots, understanding hotspots are so the larger contributors can be targeted more efficiently. Again, not all the little nuts and bolts. Collaborating, again, I keep saying this, collaborating to improve the data, target the emission source, and then start to decarbonise your materials and your processes. You can't just do it. I've got no kind of sway over where the steel comes from. It's largely through a framework. But if I start the communication, like this is where all our carbon's coming from, what can we do about it? Starts the cogs turning. Circular approach, do all this again. Once you've done it once, you'll have a ton of data, and it'll be way easier on the next project, and then you'll start to decarbonise that kind of decaying curve going down and down. But make sure your designs are future-proof. Provided those designers and constructors with better tools to appreciate how the carbon is playing out in their designs, instead of doing all the little manual calculations, would really start to bring decarbonisation in a more accessible form, not just to the carbon specialists in your companies. That's me. Do please come find me after this if you want to collaborate. exchange contact details, see what we do. I don't really want a sales pitch, but I want to know how we can all decarbonise together, how we can integrate with the scheme owners and get through this. Because we're only going to get through this together, so there's no point trying to do it alone and being big shoes. But yeah, thank you very much.